Hello, Chairman. Because the time is delayed, so Professor Chen Fahu actually is on the way to airport. He asked me, I'm from Tsinghua University, Kunyang, and to make my presentation first. And meanwhile, he asked his colleague, Professor Tao Wang, to make his presentation. So please let Professor Tao Wang come in the meeting room.
Yeah, Professor Yang, I'm already in the meeting room. Okay, thank you.
So I will give presentation first. Or you start?
Yes, maybe Professor Yang, you start first. Okay.
Okay, so let me share my screen. Can you see my screen? Hello?
Yeah, yes, we can.
Okay. So my presentation title is characterizing temperature change on the Tibet Plateau, and this is a synthetic study. We present the overall warming and the local cooling. This is the outline. First, I present the overall warming on the Tibet Plateau, and particularly present the elevation dependence of warming, which has been mentioned many times today. And then I try to explain the
We have some problems with the internet connection. We do not hear you. Can you hear us? Some technical problems with the internet connection. We did not get the last sentences.
Professor Yang, we have the problem that in listening you. So maybe you have some problem in the internet. Yang 老师.
Professor Yang, can you hear us?
Yeah, I think there's maybe some technical problem. I mean,
Professor Yang, if you can find a better internet connection, we can move your talk to a later position.
On the Institute of Tibetan Plateau, and actually Professor Fahu Chen, he was on the, he's because have some emergency, so I will on behalf of him to talk about the climatological network on Tibetan Plateau. So actually we have the three major messages I will present here. The first is about Tibetan Plateau, and is the basic characteristics about the climate change. So actually the collision of Indian plate and the Europe plate give rise to the Tibetan Plateau, and they have the total area of the 3.1 nearly million per square kilometers, with nearly 2.5 set in China. And we have very high elevation. The mean elevation is above the 4,000 meters. And we also call it the Asian Water Tower. And because of its high elevation, so the plateau holds the nearly the glaciers, the permafrost, and the snow cover. And because of its cold and the dry climate, so the vegetation is mainly over 2/3 of the vegetation is covered by the alpine grasslands, and the forest is mainly limited to the southeastern area because of the South Asian monsoon. And not only Tibetan Plateau has a very have this glacier snow, but also have, because of this surface high albedo, so it can also impact the Tibetan Plateau on the surroundings. For example, it can excite the extratropical atmospheric connections, including the Africa, Pacific Ocean, and also some studies show that the Tibetan Plateau can also have impacts on the climate in the USA. And now I would like to draw attention to about the basic characteristics of a climate region. And in climatologically, the annual mean temperature is decreased from southeast to northwest. And similar to the Arctic region and other alpine and high altitude region. Tibetan Plateau has warming very fast. It's about twice as fast as the global average since in the past 3 decades. And for the precipitation, actually, the Tibetan Plateau is relatively dry compared to the surrounding regions. And actually, there are four major moisture pathways. The moisture is mainly come from the South Asia summer monsoon in the summer season. And in the winter season, that is the westerly that is mainly dominate over the South Pole. And because of these characteristics, so climatologically that Exotic basin has a higher precipitation than the Indo-Hic basin. But in the past few decades, because of the weakening of the South Asian monsoon, so the southern basin that actually have become drier, but the Indo-Hic basin that are dominated by the westerlies become wetter. Because of this precipitation change and the warming, rapid warming, so there is a dramatic changes in the land surface processes. For example, there is an overall ice loss that over the Tibetan Plateau, but as we can see, there's the gain that is northwest area. We also call the Karakoram anomaly, and also we have an over reduction of snow cover. But for the lakes, we can see there's a north-south contrast in the snow in the lake area. That there is expanding that in the northern regions, but there's a great shrinkage in that in the southern region because of the weakening of the South Asian monsoon. And also we can see that the vegetation displaying a dipole pattern that there is a browning that in the western region, but in the greening in this northeastern region. And actually the models is not really have very better performance that in simulating the climate characteristics in this region. So I take an example to show that currently the most out of the start of the CME6 models have wide bias. And this bias is very high in Exo-Hic basins and the Indo-Hic basin. And also almost all of the CME6 models simulated a high venting trend, and it is failed to capture the contrast between the Exo-Hic and Indo-Hic precipitation trends in the last 30 years. So this means that the models currently that have better performance. But the models is an important tool for obtaining this climate information, especially in these complex terrain areas. But these models have some big problems, so we need, some observations to reduce the models, to constrain models, to improve model performance, that is especially for future projections. So I would like to draw the second part about the ongoing observation network on Tibetan Plateau. And actually our institute have set up a very comprehensive field stations on Tibetan Plateau. For example, there is nearly 60 domestic comprehensive stations on Tibetan Plateau. And also we have international field stations that is outside of the Chinese territory. And also the 8 stations is operated by our institute, including 3 national stations. And also we in Tibetan Plateau, they also perform the scientific observation experiments. For example, the high water experiment to try to understand the water processes in this region, and also the game and camp Tibetan, and the TIPE PBL is try to understand the boundary layer and to understand the boundary layer and its impact on the climate, local climate. And also they also perform some routine observations. For example, for the weather stations, you can see that there is almost 167 stations operated by the CMA, and also the hydrological stations that operated by the Ministry of Water Resources of the China. Actually the Tibetan Plateau is generated by the collision of the Indian plate and the Euro-Asia plate. So there are so many earthquakes that happening that in this region. So there are also some seismo stations operated by the China Earthquake Administration, and actually they really help us to understand the processes underlying these processes. To serve the regional sustainable development and meet the needs of the Earth system science, so especially the Earth system model development, it is really urgent to coordinate the existing observation system on the South Pole in a manner to graduate build a new observation system, the International Observation Alliance of the South Pole. So the final part is about the integration of the observation model data. And the mission is try to promote the Earth system science, and it's developed our own Tibetan Plateau Earth system model, because we have a different models, the global and also regional, but all of these models have some problems that in simulating the capture the real processes of the occurring in the Tibetan Plateau. So we really to have our own model and to tailor to the specific processes. And also, when we have this model, we really want to have a realization of local sustainable development, because Tibetan Plateau is also called Asian water tower. So the waters is also very important for the downstream areas. So if we really have a very good project to have a clear message, a clear picture of the future, we really need a good model. And the idea is to build a space airborne ground integrated LOT observation system, and it's consisting of the field observation system and a remote sensing observation system. Currently, actually, we have this. We have almost have the very comprehensive field observation system, and in the maybe of 2 to 5 years, we will try to have a remote sensing observation system to store that over the Tibetan Plateau, and to compare this observation, integrate the field with the remote sensing, this system to really to understand, to map the characteristics of the surface characteristics of the Tibetan Plateau. And for the model that we have the 3 stages. So the first stage is that we have the Tibetan Plateau climate system model. And in this model, we will mainly focus on atmosphere and soil and complex terrain to try to understand the interaction between them. And the second stage is that we should have the Earth systems, Earth surface system model to try to include the biogeochemistry and water resources, cryosphere and atmosphere, to try to put them together and to really understand the climate change impacts and their feedback to climate change. And the third stage that we should have the final Tibetan Plateau Earth system model. So in this model, so we should include the lithosphere processes, a lithosphere into this surface model to cover the surface and a deep surface, a deep layer together to try to understand the Earth system, the evolution of the lithosphere and its impact on the surface climate. So actually, currently, land surface processes,
Professor Fahu, can you hear us? We have some technical problems with the connection. Yes, the internet connection is not good. We have some technical problems. Also, time is very short. Can you go to your...
finished, yeah.
Okay, can you go to your conclusions, please? Can you hear us? There are some problems with the internet connection. We do not hear you. I think that we have to to skip to.
Yeah, okay. So I have just the remaining the 2 slides. Just to finish the 2
okay,
slides.
just move to
Okay, just 2 slides. Okay. So continue. The first the above slide that is mainly talk about the Tibetan Plateau climate system model. Currently, we have the very good, progress about the climate system model. And actually, in our institute, we also have a data platform we call the National Tibetan Plateau Environment Data Center. And actually, so this data set, this platform is designed following the fair data sharing principles and hosting the more than 4,000 data sets related to the domestic and international Tibetan Plateau Earth system science. And we have the climate data, hydrologic data, and the biological data, and also have the more than nearly 45,000 registered users. And this data set is certified by Springer Nature, AGU, and ESSD. And so you can access the data set freely. And also this center is the user hub, is served as a 3 aims: data archiving, integration, and the services. So we have the research centers and national data centers, CAS data centers, the National Science and Technology Programs, and the CAS Science and Technology Programs. And so these centers have exchange cooperation between this TPDC. And also we have some programs. And we have the international data centers, international science and technology programs, and many international organizations. So based on these programs, we can have the data that transferred to this DPDC. So this DPDC is growing, and is in the future will become a very big data set, a database that for studying the Tibetan Plateau Earth system science. Okay, so I finished here. So thanks a lot.
Thank you very much.
So Professor Yang, can you hear us? So maybe it's your turn, right?
Okay, so this was Tao Wang, which was the speak of Chen Fahu.